Okay, so today we are seeing the about the practical of computer science. So in that we'll see about what are the phases required to write any program or you can say a problem. So for that purpose, we have to follow these steps. So see, this is the introduction about the programming phase. So these are the steps you have to follow before writing a program or before implementing any program here. So first one is a problem definition, then problem analysis, algorithm development, then coding will come, then program testing and debugging, and then documentation. So what is problem definition? So whenever you are doing any program, first you should understood what is the problem is there, what is the question is there, what problem you have to deal with, what are the requirements of that problem to design a program, what are the basic necessities for the program that you have to design or that you have to decide in a problem definition. So in practice, to solve any complex or real life problem, first we have to define the problem as. So how to define the problem as? These are the some criteria you can say. What computer program does means when you will write a program, what kind of output will get generated? What task will it perform? It means for what purpose you are designing that program or what purpose you are say creating a program. So what kind of data is required means what kind of input you will give, what kind of process will be takes place, and what kind of output will be get generated. So all these things we have to determine or we have to decide at the level of problem definition. So once you understood the question, what we have to do with this program or what we have to do with the question or problem, then we can go for problem analysis. That is the next step, problem analysis. So what is in there in problem analysis? We should know first what is problem definition means we should understand the question, what to do with that question, what we require the proper output or what we require the result. So that will be decided in problem definition. Now how to do that? That is called problem analysis. So what to do that? You should know what kind of inputs are required means what we will provide the input for the program. Now, if I say consider if I want to go for the addition, so I want to write a program for the addition of numbers. So how many numbers you want to add that numbers? Okay, so now suppose I want to show a program for addition of two numbers. So data is required in terms of two numbers here. So my input is required in terms of two numbers. Once I know the what kind of input is required, then what kind of output will get here. So now I'm doing, for example, I said addition program. So when we are doing addition program, we require two input values. Okay, minimum we require two input values, and after that, after processing, after adding those values here, what kind of result will you get? That you to decide in a problem analysis. And any other requirements required for your program that will be done under problem analysis. So once it is theoretical way is completed, then you have to go for the design of solution. So what is design of solution means? We should develop a algorithm here. Now what is algorithm here? It's called a theoretical presentation of your program or theoretical representation of your program. So still you are not completed or still you have not started actual coding here. What you have started here only a theoretical way of your problem or program. So in algorithm development, what should be the first step, what should be the second step, what should be the third step? That step by step you have to give the sequence of your problem. So algorithm is nothing but what? Step by step, finite sequence of instruction to solve a well-defined problem here. So now suppose if I take example of addition of two numbers only. So in addition of two numbers, first procedure or first step is what here? We require two numbers here. After those two numbers, we want to go for the addition. Once the addition is completed, that is called process. Once the process is completed, addition process is completed, we have to get the output here. So this is called the algorithm development. So still we are writing a theoretical way only. What is the first step? What is the second step? And what is the last step to get the desired result? That is called algorithm development. So writing in a theoretical way, the step-by-step procedure of your problem is nothing but called algorithm development. Once the algorithm is developed, okay, this is the alternate method that is called flowchart. So either you can go by algorithm or you can go by flowchart. Now what is flowchart means here? How your program is performing. Okay, what is the first step is executing, then what is the second step is executing, then what is the third one, and what is the final step here. So flowchart is nothing but what, how your program or how your problem is flowing to get a desired result. What is flowchart means? How your problem will move or will execute a step by step, or how the control will pass from one step to the another step. That will be designed under flowchart here. So algorithm of flowchart, anyone you can design to show your solution in a theoretical way. After that, your actual implementation of code will start from here. So once the, you can say, a ground level work is completed, once the problem is defined, once you know what should be the input, what should be the processes required, and what kind of output you are getting, once you have decided that, then we are going for the implementation of actual code here. That is actual program. We will start in the phase that is called development of programs or computer solution. So in that you have to do a coding or programming here. So converting your algorithm or translating your algorithm or flowchart in terms of any programming language is called coding or programming. Converting your flowchart or algorithm or converting your problem definition in terms of coding or in terms of say a syntax of that program is nothing but called coding or programming. So it is a process of translating the algorithm or flowchart into the syntax of a given programming language, such as programming languages are C, C++. So we are studying here C++ programming language. Now, once you have designed a program, once you have written a program using any programming language, say for example C++. So once the program is completed, now you want to compile that program. So compile is nothing but what? We want to check if the program is working it properly or not. That process is called testing and debugging. Now testing and debugging means what? Testing is nothing but you have to provide some input values. Say now if I say addition of programs means we have to give some values for that, and after those values when you will input you should get a desired output here. So that is called testing here. Now suppose while writing a program, if I committed a mistake, if I done some wrong thing in that program, then we have to find those errors here, find those mistakes here. So finding the mistakes and correcting those mistakes, finding the mistakes or finding the errors in the program and correcting those errors is called debugging here. So debugging is nothing but removing the say errors or removing the mistakes from your program. So this process will go on continuing, that is testing and debugging till you get a desired and correct result here. Once you are firm with your result that this is the correct result, then testing and debugging process will get over here. And once the process completed, once you are getting a desired output, then those output or those programs you have to maintain in terms of documentation. So that may be in terms of soft format or that may be in terms of hard format. So what are the phases here while doing any programming? First, you should know the question. Once the question understood, you should know what are the requirements for that program, means what kind of input or data is required, what kind of operation or process I want to perform, what kind of result should get on a screen or what kind of result should be displayed or what kind of result should come. So that should be done in a problem analysis. So that problem, what you have taken a raw data, that should be done in terms of say algorithm and flowchart, that is called theoretical presentation of your program. So once that is completed, now you have to go for actual implementation of programming or development of program. So to development of program, on which platform you want to develop that program, that you will think means which platform, which programming language you're using. So on that basis of that, you have to convert your theoretical, whatever you have done program or problem, that should be get converted or translated in terms of your syntax of that programming language. If I'm using C programming, then I have to convert my theoretical say logic in terms of a programming logic. That is nothing but I have to take such syntaxes, such programming elements of that particular languages. So if you are using C, then structure will be different for C. If you are using C++ platform, then structure will be different for C++ platform. Then once the program is completed, then you have to go for test that program. Testing is nothing but you have to run that program, you have to execute that program. To run the program, you have to follow the steps and you have to run that program. If you're getting the correct output, then well and fine. If not getting, then you have to find out the mistakes from your program. So what are the mistakes that are done in the program while doing a coding or while doing a programming? So those errors you have to remove. That is called debugging. Removing errors is nothing but called debugging. Find out and correct the program, and once again test that program till you satisfy with your desired result. So once you get a desired result of your program, once you got the solution of your problem, or you can say program, then documentation. Documentation is nothing but that program will be kept it in terms of soft format or in a hard format. So these are the basic steps while writing any programming language, okay, or any programming, or you can say any program. Now here we are using a software for your lab purpose, that is C++ programming, and software we are using TCC, that is Turbo C++ compiler. Software you are using for C++ programming is what? TCC, that is Turbo C++ compiler, and whose interface will look like this way. So this is the interface of your Turbo C++ here. You can see here menus are written here. So these are the menus that they say file, edit, search, run, compile, debug, project, option, window, and head. Now, what is the use of file here? In file, you can create your new file here. Whenever you are creating a new program, you require a new file here. So click on file, you will get a new option there. You have to click on new menu, you will get a new file with the file name as no name 00.cpp. You get like this way, no name 00.cpp. Now, what is CPP means here? It is the extension of your C++. So where the files are storing in which format? .c++, that is CPP. So C++, it is the extension of your C++ editor. Okay. In file, you get other option, that is save. Okay, save as, open. So these file options will get in a file menu here, or these are the options will get in a file. Now, once you have completed your program, because this is called a compiler, okay, so compiler means what? It is used to compile the entire code here. You cannot you cannot write half program and see the output. It is not possible in compiler. You have to write the complete entire program from the starting point to the end point, and then you should go for the compilation. So what is the use of compilation here? Because here this is .cpp file is there which you have created. User has created .cpp file. Means you will write a code or programming code in this editor. So once you are done and once you go for compilation, then compilation will be creating the say object file. Okay, it will be created object file, that is called machine level file, because you are writing in a plain text format. Okay, you are writing the program in terms of English plain text, okay, or plain English text, but that should be get converted in terms of a binary, that is 1 and 0, and that will be taken care by compiler. So compiler will convert the source code to the object code. Compiler will convert what? Source code to the object code here, and after that you will run that file. So see here, one more is there here, tab, you can say run. So when you run that file, that is called executable file here. So here three files will be get created. One will be created by the user, that is .cpp file, which you can see here, .cpp file. One will be created by the compiler, that is .obj file, that is object file, and one file will be created by run when we run the program, that is .exe file, that is executable file. So for one program, total three files will be generated. One is source file, one is object file, and one is executable file here. So three files will be get generated for one program or one code here, or you can say one coding or one program. So this is your Turbo C++ editor where we are typing the code here. Okay, I'll show you later one by one all these things. Now, introduction about programming elements. So before writing the program, first you do define a question. Okay. Now I'll just show you here one small task. Okay, with the addition of two numbers. So this is my problem definition. I'll show you your problem definition. So what is my problem definition? I want to add two numbers. Add two numbers. Add two numbers. Say this is my problem definition. Okay, add two numbers. So write a program to add two numbers to generate a desired output. After that, I have to analyze this problem. So problem analysis. So what is analysis? For addition of two numbers, what I require? So I require input of two numbers. So input two numbers. I want your input two numbers, say A and say B. and that I want to store somewhere. So for that purpose, I want first process. So what process required here? So process is, I want to add these two numbers. So process is say A plus B. That is my addition. And then I want desired output for this. So output, so desired output. That is addition of two numbers. So desired output say I will store in Z. So that is nothing but my output. So what is the form here? Z equal to A plus B. So this is my problem analysis. Now algorithm development will come and flowchart development will come. So I'll just show you the flowchart. I'll show you the algorithm. Okay, anyone you can do it, algorithm or flowchart. So algorithm, I'll do it here. So what is the algorithm? You have to write down the step-by-step procedure. So step one, I have to start my code here. Okay, so step one is start. Step two, see, I'm seeing the analysis and I'm doing the algorithm. Step two, I want to input two numbers. So input say A comma B. Then step three, I want to do the process. The process is what I've written Z equal to A plus B. This is my process. Then step four. Step four is what my desired output. So say output Z. And once the desired output is completed, step five is stop the process. So this is called algorithm here. This is the algorithm. So by problem definition, I understood what is the analysis required. I require two numbers, say A and B. Then process is what addition of two numbers, and then desired output. Okay. The same thing I implemented in terms of algorithm. What is the first step? What is my second step? What is my third step? What is my fourth step? What is my fifth number step? So either you can do it algorithm or you can do it flowchart. So to do flowchart, there are various symbols are there which we'll see in the theoretical class. Okay. So we require here what? The symbols to design a flowchart. So flowchart I will tell you later. So just you be with no algorithm, because algorithm or flowchart both are valid here. Okay, either you can do it with the algorithm or you can do it with the flowchart. Now all of you know how the program is flowing here now. How the program is flowing? We require input, then we require process, then we require output, then we require stop. So this is my say I'm inputting here or I'm reading here two values. So reading two values or inputting two values. Here addition process. This is my addition process. Or you can say formula addition process or computing two numbers addition process. And this is my say printing output or printing result. Printing result. So like that you have to do it first theoretical way. Now you have to go for implementation of actual program. So before implementing, we should know the basic elements of your programming. So basic elements, say basic elements of say C++ program. What all required for the writing of the program? Say programming. Okay. So first we require the hash. Hash is called a preprocessor directive. Preprocessor directive. Preprocessor directive, that is hash. Okay. Later we require okay preprocessor directive. Then we require some header files. We require some header files. So now basically which are most important header files that I'll tell you. So we require here say iostream.h. This header file. I'll tell you what is the use of this. Then we require say conio.h header file, and then we require here say okay basically you consider these two. So these are the two basic header files required for all programming here. So iostream.h and conio.h. Now what is the use of iostream.h? I stand for input, O stand for output. So input output stream. Stream is nothing but flow, and it's a header file. So in this header file, there will be two, you can say, functions, or you can say operators will be defined, that is input operator and output operator. So which you are using in a programming, that is C in and C out. You are using these two words here. Those two words working, you can say, defined in this header file. Working will be defined in this header file. And in conio.h, we are using two functions, a CLR, a CR function, and we are using get ch function. So these two functions we are using. So clear the, that is CLR SCR function is nothing but to clear the screen. If you want to clear your program, or you can say output screen, that time you are using CLR SCR function, that is clear screen, and get ch function to combine your input and output screen, you can say. So these two functions working is defined conio.h. Okay. Then we require a main function. We require a main function where we want to write a main code. Okay, so actual coding will start under main function. So under main function we require open brace and close brace, and within that we are writing the entire program. We are writing what? Entire program. So when you are writing entire program, we should know what kind of values we are using. So now suppose I want to use the whole number, say like 2, say 3, say 4, 5. So when we want whole number, that time I have to use int as a data type. I have to use int. Int means integer, either positive number or either negative number. So int. Int is nothing but integer or whole number. Integer. Suppose I'm using such numbers, say 2.4, say 4.6, such kind of numbers I'm using. Say 4.5, such numbers I'm using. Such numbers are called floating numbers. So I have to use here float. I have to use here more float as a data type. So there are various data types are there. Basically now you understood these two data types, int and float. Int for the whole number, float for the fractional number. Okay, got the idea? So this is will come after main function. After the open the brace, we require this. So all together it is called, okay, this all together it is called, I'll just show you here. So all together it is called your, all together it is called, say here, right, declaration of, declaration of variables. Declaration of variables. So main function, after main function open brace, and after open brace we can declare the variables either in terms of integer or either in terms of float here. Float means fractional values, integer means whole numbers. So it is called declaration of variables. Okay, after that your input will start. So declaration of variable is over. Now input will start, because we have seen in the algorithm first start is there and after start input is there. So what input is required? So input will be done using the same operator, you can say cin. So like this way, cin, how many variables you want to input, that you to write. So say a, say b. So input is nothing but input, that is cin, that is called insertion operator, cin. Okay, that is your cin is your what, just a minute. Cin is your console input. Cin is what? Console input. That is extraction operator. Okay. Cin is what? Extraction operator. So here I write console input. That is Cin. Console input. So Cin input is over. Now you have to go for the process. So process. So for process, we have to use the remote formula. Say I have taken z equal to a plus b, because I told the example of addition of two numbers. So z equal to a plus b. So this is my process here. And once the process is completed, I have to go for the output here. To go for the output here. So for output, I have to use here C out here. C out, say Z, because Z is my result where I have stored. So C out Z. with a semicolon. It is not a programming part, okay? This is just a brief idea how to write a program. We are not written still actual program, okay? So this is output, console output, okay? Where the result will be stored here. And then closing of your program. So see basically what we require mostly here while writing a program. You should understand first question. Once the question is understood, you should know what are the requirements for that program implementation. Say what we require input values, what formula is required, what kind of result we will get, where to store that result. And then you have to go for implementation of program. So this is just I have told a theoretical way. Still, you have not implemented actual code here because still you have not opened the application that is C++ editor. Okay. So this is a brief idea. In the next session, we will do the actual implementation of the code or program using a C++ editor. So using C++ editor, we will do a next lab, a actual program code. Okay. So we'll stop here. We'll see other part in the